Right, a box contains 5 red balls, 1 green ball and 6 pink balls. 2 balls are to be picked at random without replacement. Find the probability of picking 1 red ball and 1 green ball. Right, so when it says here without replacement, what that means is once a ball gets taken out of the box, it doesn't get replaced, okay? So it gets put to one side, they don't put it back in the box, okay? So it's important to remember that when we are dealing with then taking 2 balls out or 3 balls out. So part A then, it says probability of getting 1 red ball and 1 green ball. There's actually 2 ways of doing this, okay? So if I write P for probability, you could get a red ball out to start with, okay? And then the second ball could be a green ball, okay? So that's one way of doing it. Or, alternatively, the first ball could be a green ball and the second ball being a red ball. So there's two approaches, 2 ways you can get the outcome, the desired outcome here. Okay. Now notice the word and, right? So we're going to multiply these probabilities here together now. And first of all, we'll look at this particular possibility here. So first ball picked out is red. Now, if you notice, there's 5 red balls, and in total there, I think that comes to 12, doesn't it? If you think 5 red balls, 1 green ball, 6 pink balls, there's 12 in total. So you've got 5 chances of it being red out of 12. Now, we're going to multiply now the second one, probability of it being green, okay? And this is where you have to be really careful because it said without replacement. So if you think about it now, we would have already taken out a ball from the bag, okay, would have taken out a red one, wouldn't we? Okay, so we would be left then with 11 balls left in the box, okay, there'd be 11 balls left in there now because one's already been taken out, the red one's been taken out, and out of the 11 you've got, what, 1 chance of it being green, okay, so then you've got that there, so you're going to multiply them together. So when you multiply them, 5 times 1 is 5, 12 times 11 is 132. Okay, going the other way, green, red. Okay, so the first, you've got, first being green, you've got 1 chance out of 12, haven't you? Okay, because there's 1 green ball out of a total of 12. Then, of course, that green one's been taken out, so now there's only 11 balls left. And then the probability of getting it red, then, when you've got 5 balls there. So you've got 5 on the top, and again, 1, 3, 2 on the bottom. So you've got this approach, or you've got this approach. So it's given us more chances of getting red and a green. So we're going to add them together then to get our total answer. Okay, total probability. So you get 10 out of 132. Okay, and there's our answer. There's no need to simplify it. Find the probability then, part B, of picking at least 1 red ball. Now to get at least 1 red ball, okay, the first one could be red, yeah? And then the second one could be anything, couldn't it? It could be green or it could be pink. It wouldn't matter. But when it comes to probability, you have to consider all the possible outcomes. So it could be red first, could be green, or it could be red first, could be pink. Okay? Now, it gets even more complicated because the first ball doesn't have to be red. The first ball could be green and the second ball red. Or the first one could be pink, second one red. Now there's a lot of things to work out there, but a better way, right, there is a better way, is to think of it this way. At least one of them red. Well, you could say the first one being red, the second one not red. Okay? So instead of thinking about green or it could be pink, just think of it not being red. Okay? In order to do that, the notation then is that. Okay? So that would be saying the first ball is red, second one is not red. Okay? A bar above just means not red. Does that make sense? Okay, so when it comes then to it not being red, you're actually putting the green and pink together. Okay, so but maybe by the side here, I'd write how many are red. I've got 5 red, haven't I? And not red would be 7, wouldn't it? Now that would sort of include the green and the pink. All right, so at least one of them being red. Well, I could have it this way, or of course the first one doesn't have to be red. The second one could be red, couldn't it? Or there is actually one more possibility. If you think about it, at least 1 red. Well, both of them could be red, couldn't they? Yeah? Both of them could be red. So you need to consider that as well. So let's go through it. Probability red, not red. Okay, so probability red, well, you've got 5 chances out of 12 times then not red. Well, not red, don't forget now, there's 7 balls in there that are not red, 1 green and 6 pink. So the first ball that gets taken out is red. There's still going to be 7 that are not red, but there'll only be 11 then total because ball's been taken out. So work that out, you get 35 on the top, 132 on the bottom. The other way then is not red, red. So not red, you've got 7 chances, of course, out of 12. Red, you've got 5 chances out of then 11, of course, because 1's been taken out. This is the same, 35 over 132. And then the last possible way could be both of them are red. Now here, of course, both of them red. The first one being red, you've got 5 chances, of course, of being red out of 12. But then be careful, 1's been taken out, so you've only got 11 balls now. But also 1 red has been taken out as well, so you've only got 4 there. So that would be 20 on the top over 132. So you've got this possibility, or this possibility, or this possibility. To finish off, you need to add these together then. Okay, so 35, 35, and 20 is 90. Okay, so you get 90 over 132. And there's our answer.